processing. And the next topic will about how do we do the tokenization. We actually have an out-of-box experience for large language model tokenizer. So I will introduce that part and give a demo. How do we do that with just 1-2 lines code? And yeah, that's today's agenda. So before we deep dive into the details, I probably will give some quick facts about what the ONNX Runtime Utility is. So ONNX Runtime Utility is a project that we aim to solve the pre-processing issue for the ONNX Runtime. So it's a separate repo in the ONNX and the Microsoft GitHub org. So you should be easy to find that. So there are some key features about our ONNX extension is that first is API compatible with ONNX Runtime. So this is when we develop from first era, we want to be have a better modularization, and we want to also separate component for so that we can release those stuff in the independent schedule, and we have a better engineering process. So it's also available for all the ONNX Runtime and served platforms and developed languages. You already heard a lot about the ONNX Runtime support multiple platforms in I think the mainstream platforms and languages were already supported. So ONNX Runtime extension actually have the similar package to support those packages. So which will save a lot of efforts for user to build package by themselves, or they need to develop any language binding by themselves. This is already done by extension project. So as I said, that just we already have this package, so it's very convenient for user to use it in any long Python environment, and in the client or the web app. Actually, it's now is widely used in the Microsoft internal app, Office, Windows, a lot of apps, and we also have some third-party adoption. So another feature of the ONNX Runtime extension is that it actually have a very better modularization, which means that if you want, because as I mentioned, the ONNX Runtime extension has support a lot of domains, so it includes a lot of operators, but those stuff can be configured. If you want to build from source and only want to choose what the only domain you want to use, you can just give a config file and list what you want and build from source, and you can get the binary you want only contains what you want, and it will be very good for some footprint sensitive scenarios. So another thing is that ONNX Runtime is an open source project, and we welcome a lot of contribution. And it did was some operation and processing actually was contributed by several other teams and even the external customers. So and in the ONNX Runtime extension, it's very easy to add new pre-processing operators. It's just add one function and add a register item entry. That's all. That's where you can see a lot of example in our ONNX Runtime extension. So this is a architecture graph. Is show what I summarize what I just said. So the core part of the ONNX Runtime extension is that we have a set of the post processing operators which are already implemented by the C++ language, which can be ported into the every platform with language binding, and it can be compiled as a different package like the Java package and the .NET package, mobile package, all of this stuff. So it communicated with ONNX Runtime or by the C API, which means that it's have a backward compatible with ONNX Runtime, and you don't need to have to be select the binding version between the two components. It's backward compatible, and you can just choose what the version you want and use it in your app. So beyond those stuff, C++ and stuff, and we also have a processing graph tool, a set of processing graph tool generation tool, which can help you to generate the pre-processing module for you. That I will show more details about that part in later. And we also have one feature called the Python op in on runtime mutation that you can just use Python function as a ONNX operator, and this can be used for the debugging when you want to debug some scenario in use some Python to debug some model and there's some Python already missing. You can just wrap this Python function and inject into the model, and you can get the end-to-end debugging work. So beyond that, we have all these kind of the APIs and for application, you can just use it in your app as your language. So next, I will talk about only one-time data processing. So data processing is a very important part. You actually mentioned in the morning that when all the inference engine are focusing on to optimize the tensor computation performance, but for the in the reality, when you develop the app, actually the input are just image and raw data text. Those things have to be processed into the tensors that can be used by the inference engine. So this is actually the big gap, especially when you run those develop your app on the long Python environment. Python actually have a lot of libraries and some code are actually already support well for the pre-processing. But for other platform and other languages, actually, there are no good solution for that. So if you are familiar with other OIL framework, they also have some similar processing libraries to help that. For only one time, so we developed the only one-time extension to be the solution. So basically, this is the common repro to hold all the pre-processing algorithm and implementation in one place. So it's equivalent to if you are familiar with PyTorch, you should know that they have the PyTorch vision and PyTorch audio, PyTorch text to do the pre-processing stuff. It also, I think, the only one-time intention have those equivalent features, and that second is that the major usage for only one-time intention I mentioned is that it's very convenient for the long Python environment usage, and also yes, it does support Python as well. But I think that the key customer is that when you deploy your application, develop the without Python, that's very important for you. That only one time can help on that part a lot. So as I said, that's very easy to if you found something missing for your scenario, and you are be able to write some C++ code that is very convenient for you to compute the operators. And we already integrate a lot of common third-party libraries for the image processing and the audio processing, those stuff. So actually, you just use some C++ code to stitch some steps into operator. That's all. It's very easy to do. Compared to the other solutions, only one-time mutation we have several distinct features. One is that it's state-driven. For only one-time intention, we organize most of the pre-processing into an ONNX graph. Actually, this is a model. It's also a ONNX model. So it's so that whole processing can be driven by those data. So you for the user, you just customize your data, and you can get the pre-processing logic as you want. So it's and we also did a lot of work to optimize that for the web and the mobile platform. Is that I said you can support the selected build. You can just choose what you want, which save a lot of footprint for the mobile platform. And this and also it support on multiple platforms. And one point important for Microsoft is that for Microsoft we have a high standard of the code security requirement. We for extension we have also meet those stuff so that the user don't worry. It's very convenient for the Microsoft 1P partners. So they have a lot of some corresponding component in other framework like PyTorch. PyTorch has the Torch Vision, Torch Text, Torch Audio, those stuff. It's very friendly in the in Python environment, and you probably have more operators than we does, but it's only Python, right? PyTorch is Py. So it's but when you develop for other platform, it's actually is a blocking issue for you. So TensorFlow also have so TF Lite, TF Task Lab, this stuff. This also have the well defined APIs. But those actually is kind of no common design. It's just for some specific task. If you want to, they have no unified solution. If you want to do some task, you probably need to search and study to find what's the right way for you. But for only runtime extension, we have just unified the whole idea and have the shared repertoire for you. So then we talk about how we if you want to use our running runtime to solve your pre-processing in your app, how do we do that? So there are a couple steps to do that. The first is that you should get create the processing graph by the only runtime intention Python API. We have a set of APIs to help you user to get the what's the pre-processing graph they want. So for the vision and the tokenization, for sometimes we build this graph by only runtime extension itself. Sometimes like the tokenization, they have the vocabulary, those data already there. I think the current popular one is that stored in the Hugging Face hub. So we have the tools to pull the data from the onion Hugging Face model hub and convert it into the format that was required. So it's I will show it later, just one line. So the second step that if you want to just simplify your inference function, you actually can merge this processing model into your core model to be just one single model that you can just do inference by by the image to input the image and some other raw data. But this is optional. Definitely, you can have the two inference step. One is the first you use extension to do the to generate the tensor, and then you pass the tensor to the only runtime. They have the two choices depending on your needs. So the third step is that when you do inference, one thing is that the only actual step is that you need to register the only runtime intention API before the session run. So this is the architecture requirement. Basically, in the future, probably we will think about if the only runtime package is installed, we probably automatically load it. But right now, you have to call an API to say, okay, you should enable only runtime intention on your session run. So that's a major step for the users. So right now we support the I think it's about the most popular domains for the deep learning models. The first is that variance. We support a lot of models for the image classification, image segment, and object detection, like the YOLO and the RedNet. All of this we have API, Python API to help you generate the processing model, and you can use that to do the pre-processing. And the second one is the tokenization, which I think that is quite popular now in the for those large language model. We actually support most of those transformer models from the Hugging Face. You can see the llama clip, Robota, BERT, the very old BERT, and this GPT, all of the stuff. Fine, we are trying to. I think we are keep up with all those updates to make sure our tokenizer lib can be compatible with all those Hugging Face transformer models. The third one is about is the audio domain. So they have some text to speech and speech to text models. I think the written formula one, most famous one is that Whisper model. We also have those pre-processing operators for this Whisper model. You can actually you can write on the end-to-end without any some extra programming requirement. So besides those popular models, actually we have some enhanced string of manipulation from the extending the current ONNX runtime standard ONNX standard ops. So it's where so if you are using a lot of TensorFlow text library, they have some very convenient string manipulation operations, and we also have similar operator here, which can help you can easily to put into only one-time intention from the TensorFlow. Next, I will spend our time specifically on talking about how do we do the tokenization. I think that's a very hot topic in the recent days. So the specific tokenization for the transformer models that the step is that we said that they have two ways to create those tokenization model pre-processing models. So either you can create a tokenization from the use the tokenization lib, and you just for the GPT for the BBP models you can just fit in with the vocabulary and the merge rank stuff, and you can build the model stuff. That's if you are familiar with that part, is also doable for you. And a lot of most convenient way is that you can use our ABI called only one-time intention gene processing model to just get the model from either from the Hugging Face hub or your local folder to generate ONNX runtime processing model. I think that the later one probably more welcomed, and I will show that in our clip tokenizer example. So that's a quick demo about how do we implement a clip tokenizer in the with only one-time intention in the C# environment. So before you create an app to do that, you should download this only one-time intention NuGet package from the link I shared. And as I said, the first step you need to get a processing model. So that's actually just one line for that. If you look at this Python code snippets, you can see that the highlighted part is that how we generate the ONNX module. The ORT tokenizer, ORT token is ONNX module object. So you can see that the other stuff is that you can just create a tokenizer object from the Hugging Face, source code, and then we have the generate processing module to create a one for the ORT tokenizer. That's all. And then you can use this stuff to either I said just you bind this stuff into your module, or you can use it to generate a tokenizer with only one time. So the following code is just a quick example of that how we do that. Only one time inference here is just a wrap of only one time standard API. I just make it in a one line. So when you do the inference, really when you get to the module, when you then we can talk about your application is a C#. Then we have to do when you call only one time to do the inference, there just one additional line should be added into your application. This API actually is very I think the name is just tell that what it is. Just I think that. Sorry, the space is wrong. It's just register only one-time intentions, as its name suggests. Just you should register that. That's all. After that, you can just run every API as what the normally what we did for the only one time. This you can just input the. Then you can with those intentions, then you can just input your model with a string. Previous, I think the most of module actually model require a tensor input. Now you can use the input become the raw string, so it's very convenient. So actually, we have a good example and have some very detailed examination about what happened beyond this code. So there is a link here if you are interested about that. You can click the link for the more details. So in the last section, I will talk about some the pre-processing probably not the bottleneck, the key component for the whole inference, but our implementation is based on C++, and you actually already have a very good efficiency on the pre-processing. So I just suggest for the every platform actually we also have the very good performance, and we support all those Python, mobile, NuGet, and can support a lot of platform and hardwares. And we also are working on the Java pipeline, which also release Java jar package for the user, so user can now it's already supporting the actually a lot of you can use build from source to build a package by yourself, and now we can add more those packages are listed here already can you can retrieve the package from the official package manager site. You don't need to build by yourself. You can just when you do develop your language, you can just reference this package from the package site. It's so here is some data I show about how with the processing libraries, the efficiency. As you can see, if you use the original Hugging Face wasteful processor to do the audio files, I take a 9 minutes second audio as an example. So it usually take 63 milliseconds. But with our ONNX runtime extension, the last one, you can see we extension library we have do some fusion on operation, and we also have some use some accelerator library. The precision library actually improved by 4 times. Yeah, that's actually this is for the audio domain. For the tokenization, actually, we also have the 2 or 3 times for the comparing to the Hugging Face solution. Maybe even 10 times from Hugging Face. Hugging Face have tokenization have 2 variants. One is that they have the slow version, which is is very completed, but is slower, and they also have their own faster version, which is called implemented by Rust. But even for the slow version, we maybe have the 10 times. But for the Rust version, you call the fast version, we still maybe have the 2 or 3 times on the um, faster than their implementations. So if you are hand process a lot of the text, whether you are using only one time or use only, you should consider use only one time extension to accelerate your processing time. So that's all my presentation today. So any questions?
Anybody has any questions? Anybody online has some